Coding algorithms: best practices in the ever-evolving world of software development. Mastering algorithms isn't just a skill, it's a necessity. From optimizing search queries to managing vast datasets efficiently, understanding and implementing robust algorithms forms the backbone of modern computing. This guide delves deep into the art of algorithmic coding, equipping developers with proven strategies to write clean, effective, and high-performance solutions. The journey begins with grasping fundamental concepts and progresses toward advanced techniques used by industry experts worldwide. Whether you're refining your skills for competitive programming contests or building scalable systems for enterprise environments, this article provides actionable knowledge tailored for programmers aiming to elevate their craft continuously. Fundamentals of effective algorithm development. At its core, algorithm design revolves around solving computational problems efficiently. Before diving into implementation specifics, establishing clear objectives becomes paramount. Define what constitutes success for your particular task. Is speed critical? Does memory consumption matter more? Or perhaps correctness must always supersede other considerations? Evaluating problem requirements thoroughly sets the foundation for selecting suitable methodologies later. Consider factors like input size ranges expected, potential future scalability needs, and whether there exist known optimal solutions already established within academic literature. Time complexity analysis. Understanding how execution times grow relative to input sizes allows informed decisions about efficiency trade-offs between alternative implementations. Space complexity evaluation. Assessing auxiliary storage demands helps avoid scenarios where excessive memory allocation leads to system crashes or degraded application responsiveness under heavy load conditions. Core principles behind successful implementation. A solid grasp of basic algorithm types significantly enhances one's ability to devise innovative solutions quickly. Familiarity with categories such as sorting algorithms, e.g., quicksort, searching algorithms, binary search, graph traversal techniques, BFS/DFS, and dynamic programming paradigms enables tackling diverse challenges confidently. Mastery doesn't stop at memorizing names alone. True proficiency involves recognizing patterns applicable across various domains. For instance, recurrence relations frequently emerge in divide-and-conquer contexts, whereas greedy strategies often yield near-optimal results rapidly, though they may occasionally miss global minima/maxima. Breaking down key concepts. Recursion offers elegant yet powerful ways to decompose complex tasks recursively until base cases become trivially solvable. However, care must be taken to prevent infinite loops caused by incorrect termination conditions or improper parameter adjustments during recursive calls. Contrastingly, iterative approaches provide explicit control flow advantages useful when dealing with situations involving large input sizes prone to stack overflow errors due to excessively nested function invocations inherent in deeper recursions. Strategies for efficient problem-solving. Systematic decomposition proves invaluable whenever confronting unfamiliar algorithmic puzzles. Begin by identifying subproblems amenable to individual resolution, followed by integrating those partial outcomes cohesively into a unified whole capable of addressing original query effectively. Careful attention paid early stages ensures avoiding common pitfalls such as overlooking boundary cases leading ultimately to runtime exceptions during actual deployment phases. Always validate assumptions made against concrete examples drawn directly from intended domain applications. Analyzing sample problems. Take, for example, finding shortest paths within weighted graphs, a classic scenario illustrating utility of Dijkstra's algorithm. By prioritizing vertices exhibiting minimal tentative distances iteratively until destination node reached successfully, we achieve guaranteed optimality assuming positive weights only present. Comparative analyses reveal differences between variants like Floyd-Warshall, which computes all pairs' shortest path simultaneously, albeit utilizing higher order time complexities compared to single-source counterparts offering potentially faster performances depending upon contextual parameters involved. Optimization techniques and performance enhancements benchmarking plays pivotal role determining effectiveness gains achievable via strategic modifications aimed primarily at reducing asymptotic behaviors governing primary performance metrics. Profiling tools assist pinpoint exact areas contributing disproportionately toward observed slowdowns, enabling targeted optimizations thereafter. Empirical experimentation alongside theoretical predictions sometimes reveals surprises worth exploring further. Certain heuristics unexpectedly outperform theoretically superior alternatives due largely to practical nuances unaccounted for purely mathematical models. Profiling tools overview tools like Prof offer granular insight into CPU utilization distribution per function call site, facilitating identification hotspots warranting refactoring efforts. Similarly, Valgrind aids detecting memory leaks persistently undermining long-term stability unless actively addressed promptly through meticulous resource management practices. Automated testing suites complement manual inspection procedures, dramatically increasing chances discovering subtle bugs lurking beneath surface-level functionality, appearances especially prevalent after extensive changes applied post-initial stable release versions. Debugging complex logic structures. Algorithmic constructs often involve intricate logical dependencies demanding rigorous validation protocols prior production readiness attainment. Unit tests targeting discrete components serve dual purposes, verifying isolated correctness properties plus confirming compatibility with surrounding infrastructure layers seamlessly. Edge case exploration remains crucial exercise regardless project maturity levels, since seemingly rare occurrences can trigger catastrophic failures manifesting unpredictably under otherwise normal operating conditions absent adequate safeguards implemented beforehand. Writing testable code design principles, advocating separation concerns, promote creation self-contained modules, amenable straightforward verification processes, independent external state alterations influencing behavior variability negatively. Dependency injection facilitates substituting mock objects, simulating unpredictable environment interactions, safely controlled laboratory settings. Employment static typing features available contemporary languages reinforces compile time error detection capabilities, preemptively flagging dubious assignments, violating type safety constraints, thereby minimizing erroneous runtime manifestations altogether. Version control and collaborative workflow integration. Modern collaborative workflows benefit immensely from adopting source revision management platforms, streamlining contributions, tracking revisions history attributable distinct authors, enabling seamless merges, resolving conflicts arising, concurrent edits undertaken, remotely separated geographically distributed teams. Code review culture promotes shared responsibility, ensuring quality maintained consistently across entire codebase irrespective individual contributor expertise variations, naturally occurring human workforce dynamics inherently subject change over time periods varying considerably person-to-person basis. Documentation standards. Comprehensive documentation serves multiple roles, functioning both instructional material guiding newcomers unfamiliar territory plus reference manuals assisting experienced engineers navigating legacy codebases. Unfamiliar territories requiring rapid acclimation periods. API contracts define precise interfaces allowing clients interact predictably, abstract internal workings away. End users concerned solely functionalities exposed externally through well-documented endpoints conforming agreed standards, ensuring interoperability across disparate ecosystems harmoniously integrated together. Style guidelines for readable implementations. Consistent naming conventions enhance readability, substantially reducing cognitive overhead required. Interpreting variable/function purpose, instantly recognized familiar pattern recognition. Hues embedded conventionally accepted norms, established widely adopted coding cultures globally. Adherence. Modular architecture principles encourages encapsulation, promoting reuse opportunities, simplifying maintenance routines, substantially lowering barrier entry thresholds faced novices attempting contribute meaningful enhancements. Existing bodies work despite limited prior exposure, field-specific technicalities involved. Commentary. Best practices. Effective commentary clarifies intentions behind convoluted expressions, obfuscate natural language interpretations, possibly misinterpreted naive observers lacking sufficient background knowledge, requisite full comprehension underlying rationale motivating particular implementation decisions taken. Avoid redundant explanations merely rephrasing syntactically identical statements already apparent source code itself. Focus instead elucidating why specific technique employed rather than simply describing what accomplished mechanically performed operations executed sequentially linear fashion. Real-world applications and industry trends. Current technological advancements increasingly rely upon sophisticated algorithmic innovations fueling breakthroughs across numerous industries ranging healthcare diagnostics aiding personalized treatment plans through predictive analytics models analyzing voluminous medical records accurately identifying disease progression trends previously undetectable conventional examination methods. Transportation sectors utilize route optimization algorithms dynamically adjusting traffic light timings responsive fluctuating congestion levels detected IoT sensors deployed strategically throughout urban landscapes improving commute experiences commuters encountering daily bottlenecks routinely encountered metropolitan regions experiencing population surges annually. Emerging technologies influence machine learning fields leverage advanced clustering algorithms categorizing massive unlabeled dataset segments, autonomously discerning hidden relationships forming foundational elements neural network architectures. Responsible groundbreaking achievements AI research pursuits advancing automation capabilities exponentially surpassing traditional rule-based expert systems historically constrained rigid predefined condition checks limiting adaptability novel situations arise frequently encountered evolving digital landscape continually reshaped disruptive technologies emerging regularly. Blockchain technology relies cryptographic hash functions generating unique identifiers immutably recorded decentralized ledgers ensuring transparent audit trails resistant tampering attempts providing trustless transaction environments. Fundamental cryptocurrency ecosystems securing financial exchanges securely verifiable publicly accessible immutable proof existence transactions conducted peer-to-peer networks circumventing centralized authority intermediaries. Traditionally mediating value transfers traditionally mediated trusted third parties susceptible corruption risks prevalent hierarchical organizational structures vulnerable insider threats. Conclusion this exploration has illuminated myriad aspects concerning proficient algorithm coding spanning from foundational theories to cutting-edge developments shaping tomorrow's technological frontier. Mastery entails ongoing commitment perpetual learning cycle embracing new methodologies introduced regularly expanding horizons possibilities await discovery ahead. Whether embarking upon career journeys exploring algorithmic frontiers or seeking refinement current competencies attained thus far, applying discussed strategies consistently yields measurable progress observable tangible outcomes achieved through disciplined practice sustained effort invested progressively incrementally enhancing capabilities inevitably culminating mastery sought diligently pursued relentlessly.